The third method for the preparation of sample for transmission electron microscopy is mechanical and argon ion milling. So first what you will do, you will cut the material from the bulk, and even this material is of very small dimension. The length will be about nearly 3 millimeter, and depth or thickness will be 300 micrometer. So once you have a sample, then you have to further reduce the thickness to much lower dimension, for example 100 micrometer, and this thinning of sample can be done by mechanical means such as mechanical grinding and polishing. The third step is you have to reduce the thickness from the middle to much smaller dimension such as 20 micrometer, and this step is also known as dimple grinding. So the first step is mechanical, the second step is mechanical, the third step is mechanical, and the dimension at the center will become so thin, nearly to the dimension of 20 micrometer. Below this dimension, it's very hard to cut any material from the middle by any mechanical means. Therefore, you have to shift from mechanical to argon ion milling. So you have to set operating a starting voltage and then incident angle. For example, here I have shown 5 kilowatt and 10 degree, but these starting voltage and incidence angle vary from material to material. But the final dimension in the middle will be so thin that it will be a semi-transparent, so that this sample qualifies for the transmission electron microscopy. If the thickness is more in the middle, then this means they will act as a barrier for electron beam to pass through, and you will get nothing. So to qualify this sample for transmission electron microscopy, the middle dimension should be so less that it acts as a semi-transparent. And the other thing that you have to be very careful about this sample preparation is that this sample should not be overheated. If this sample is overheated in any of the step, the first mechanical, second mechanical, third mechanical by dimple grinding, and the fourth one by argon ion milling, if there is heat involved in this sample preparation, then there is a chances that the microstructure of material will change. If the microstructure of the material is changed, then the whole process will go to the garbage. So you have to pay attention such that the material property will remain the same, both physical and chemical properties. If the microstructure is changed, then it's become useless for you to put these samples in the transmission electron microscopy, because you already distorted the material. So to save this material from this overheating, you can use a liquid nitrogen cooling stage. So whatever method you are using, you have to be very careful, such a way that the material should not be overheated and the thickness should be so less that it is just like a semi-transparent. A very interesting observation can be made for the sample preparation is that the people who prepare sample for transmission electron microscopy, they are very highly paid technicians, and their skill level is so much high that the number of people who are available in the market who prepare transmission electron microscopy sample, they are so less, so that they are paid very heavily to prepare the samples. So if you want to become a technician to prepare sample for transmission electron microscopy, then for sure you will get a very high salary and your demand will be always raised. So people will look for you, that is there is some person who can prepare the sample for transmission electron microscopy. If you are expert in sample preparation transmission electron microscopy, then you will be like a gold or diamond. Your salary will be much high, and the demand of your skills will always remain high. And this thing is not applicable for the other type of electron microscopy, such as the SEM, scanning electron microscopy, because the sample preparation is relatively simple, and even a less trained person can easily prepare sample for scanning electron microscopy. But in case of transmission electron microscopy, a very high skills are required. Transmission electron microscopy has an application to vast variety of fields such as material science, geology, environmental science, general biology, and medical science. And transmission electron microscopy is used to examine the structure, composition, properties of specimen in some micron details. And you can easily investigate almost most of the materials such as metals, ceramics, and sometimes a mixed type of materials such as composite materials. It enables the investigation of crystal structure, orientations of different type of crystals, chemical composition of different phases, precipitates and contaminant analysis to diffraction pattern, characteristic X-ray analysis, and electron energy loss analysis. Besides sample preparation in transmission electron microscopy, which is very much difficult and time consuming, there are some other limitations as well, such as transmission electron microscopy cannot take color images. Colors are added after the acquisition of the image by TEM. So you can render the colors by using some specialized softwares in the PCs and the laptops. TEM cannot take image through the thick samples. So the normal thickness variation range is about 100 to 200 nanometer. If the sample thickness is in this range, then it's possible to get it's possible to acquire some image by TEM. If the thickness is more than 200 nanometer, it's too much thick that the electron beam is difficult to pass through, and if electron beam is not passing through the sample, then you will have no image at all. A standard TEM cannot image surface information at all, and if there is some charged species in the sample, then TEM you will not get anything, or the image formation, whatever you get the image formation via CCD camera or the phosphorus screen, it will have some artifacts. There are different type of image formation by transmission electron microscopy, such as QG patterns, diffraction patterns. Diffraction patterns are also known as spot patterns. Conversion beam electron diffraction, it's also known as CBED, and the ring patterns. So you have a vast variety of image formation by transmission electron microscopy, and each image formation has its own value, and the information in each of the image formation has some different type of view or different type of analysis. A very specialized mode exists in the transmission electron microscopy, that you can contrast your image formation such as a bright and dark field. So this can be done by adjusting the objective lens. So you can adjust the objective lens to get a desired image formation either in the bright field or in the dark field. That's all from the transmission electron microscopy. If you have some question or queries, then you can ask via WhatsApp group, or you can post your comment or queries in the Google Classroom. Thank you for paying attention.